Okay, this is question 3 from the Limpopo paper of June 2019. Two learners, Kensani and Mcculloch, investigate the speed of sound in a metal using an iron palisade fence. Now, first of all, remember that when we talk about speed of sound, sound travels fastest through a solid and slowest through a gas. So they're going to probably use some version of this knowledge. So Kensani taps against an iron pole in the fence while Mcculloch holds her ear against another pole 200 meters further along the fence. So this tapping on the fence is making a sound of a particular frequency. If I go tap, 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 I'm making a sound of a specific frequency. So what happens here? Mcculloch hears the sound through the iron 0.08 seconds after Kensani tapped the first iron pole. Calculate the speed of sound through the iron. So we just have to use the normal formula for calculating speed. Speed equals distance divided by, speed equals distance divided by time. So what is the distance? The distance is written here. It's 200 meters. Okay. So the speed is going to be 200 divided by the time, which is 0.08. So the speed, and remember we must be in SI units, so this was fine because this was in meters and this was in seconds. So the speed is going to be 2,500 meters per second. Okay. Then it says to you, how much later? Okay, this is the key to this question, and this is how come it's worth 6 marks. How much later does Mcculloch hear the sound through the air? Assume that the speed of sound through air is 340 meters per second. So what's happened here is it takes 0.08 seconds for the sound to travel through the iron of the fence, but we want to know how long it travels through the air. And then we want to figure out what is the difference between the time those two take, because it's how much later does she hear it. So if we've got the speed of sound through air, we're still going to use our speed, distance, time formula, okay? But we're just going to rearrange it now. So time equals distance divided, that's not divided either, distance divided by speed. So the time here is going to be the 200 meters divided by the speed, which is 340. Okay, so then if you put this in your calculator, you get something like 0.588 seconds, which we can round off to 0.59 seconds. So this is how long it took the sound, 0.59 seconds. In 0.59 seconds, the sound traveled through the air. But it took 0.08 seconds through the iron. So how much later? We have to say for how much later is 0.59, which is the maximum time, minus, because this is in the air, minus the sound in the metal, and so you end up with 0.51 seconds. No unit, no mark. So that's where the extra marks in this question come from. They come from knowing that you must first calculate it through the air and then subtract the 2. Will the sound that has traveled through the iron have a longer or a shorter wavelength than the sound that traveled through the air? Now this is very much like a multiple choice question, okay? And you need to think about mathematical relationships here. So I want you to think about this formula here, V equals F lambda. So this sound that they made by tap, 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 tapping on the pole, okay? This sound that they made has a particular frequency. So if you cannot change the frequency here. The frequency is the same because that depends on how you tapped it. So we know that in the iron has the greater velocity. Look here, 2,500 meters per second is the speed it traveled in the iron compared to 340 meters per second in the air. So this velocity here, if you look at this relationship v equals f lambda, we cannot change the frequency, but the velocity in iron is much greater than the velocity in air. So for this relationship to be equal, v is equal to f lambda. If v gets bigger and f stays the same, it means lambda must get bigger. So the wavelength will be longer because the velocity is higher for the same frequency. Now we come to the sketch of a longitudinal wave. Okay, the sketch below is a representation of a sound produced by a trumpet. The distance traveled by the wave from the source is given in centimeters. So can you see here? 2, 4, 6, 8, 10, 12 centimeters. This is the distance. Then they say to you the speed of sound in air is 343 meters per second. Define a longitudinal wave. It has to be the definition I gave you. A wave in which the particles of the medium vibrate parallel to the direction of the motion of the wave. 2 marks or no marks for a definition. Learn your definitions. Is sound a transverse or a longitudinal wave? It is a longitudinal wave. You have to learn that. You are taught that. There's nothing you can do. You have to learn it. Write the letter of any point representing a compression. So here, this is the compression where all the little air particles are squashed together. So A, C, and E are all compressions. So it's A or C or E is going to be a compression. Identify the term used to describe the points B or D. That is a rarefaction. It's another weird word that you have to learn. Rarefaction. Okay. Give the letters of any 2 consecutive points on the wave that are in phase. So we either need 2 compressions or 2 rarefactions. So A and C are in phase. C and E are in phase. B and D are in phase. And D and F are in phase. So it can be any 2 points. So you must answer A and C or B and D. If you only put 1 point, you've got a problem, okay? Because we have to have 2 points that are in phase. A and C are 2 compressions. B and D are 2 rarefactions. Determine the wavelength of the wave. So to do this, we have to use the distance scale. Remember, a wavelength is any 2 points that are in phase. So if A and C are in phase, A is at 2 meters, C is at 6 meters. So the wavelength is going to be the distance between 2 points that are in phase. So 6 minus 2 is equal to 4. And it has to be in the correct unit. So it is in 4 centimeters, which is in SI units 0,04 meters, because we are supposed to use SI units as far as possible. But I do believe they will mark you correct if you put 4 centimeters, but if you didn't have a unit, it will be wrong. And then it says to you, calculate the frequency of the wave. So we're going to use V equals F lambda, okay? Because where's my V equals F lambda? Here's my V equals F lambda. We're going to use V equals F lambda. We know the V, they told it to us in the question. The speed of sound in air is 343. So V equals F, we are trying to find. And what is the lambda we just worked out? It was 4 centimeters. Now in this formula, because this is in meters per second, this must also be in meters, and we want our answer in hertz, which is the SI unit. So if you don't do it properly with the correct units, you will end up with the wrong answer. So you end up with 8575. Let's put here frequency equals 8575. Hertz, no unit, no mark. There we go.